Welcome to Fun with Flags. I want to talk about type-safe Bitwise operations, or how to make Bitwise operators type-safe. Okay, yeah, it works. So first we want to see why are we using bits for Boolean options. So why do we do this? And then we will have a look at the built-in Bitwise operators. Then I want to talk about the problem we have with the complement, so the negation operator. And yeah, then I will show you what my library does with all this. And finally, I want to show you some other approaches that are out there. Okay, why are we using bits for Boolean options? So first of all, they're easy to define. For example, as macros, we can just write them down. We can also write them as const x per ints, or we could also put them into an enum. So that's all viable options, all work, all are used out there. So further, or next, we have a very compact representation in memory. So a normal int, depending on your platform, holds usually up to 32 different flags. So it can't get even denser. Yeah, they're simple. We have a simple and efficient bulk transfer in interfaces. Just transfer it as an argument. And you can see it somehow as a compressed version of a std array bool with 32 entries. But forget about it right now. So, and what's also good about it, it enforces names and it prevents Boolean parameters in functions. So we could have those two functions. So on the declaration side, they may both work. So we see our options here, they have names. But when you look at the call side, there's disaster with the first one. Nobody knows what does the first row mean, the second false. If we don't have such fancy argument injection from C-line, which most of us don't have. And yeah, so here we are verbose, we have to write it out. People know what you want if they read the code. Okay, next is we have built-in support for working with bitwise operations. So we simply have this. We have the bitwise int operator, we have the AND operator, we have the bitwise AND assignment operator, we have the same for the OR, for the XOR, and then we have the bitwise negation operator, which simply flips all bits in our int. Okay, everything good. Let's go home. Really? Better not. So let's look at some bitwise operations in action. Okay.
Why didn't I think of that?
What?
I know where he's going. It's like, how do you get your enumeration values to have...
Okay, now I've got to play a little bit around here. So, okay, let's look at our first test. So this comes from the MS Windows control style, so the very old common controls. We have listbox, LBS for listbox style. And we have several styles. There are a lot more, but just let's look at the first four. We have notify sort, no redrawer, multiple selection, and yeah, we just have a function that mimics, it would create a list box. It gets an int that has the list box style inside. It prints out I'm creating a list box, and if usually LBS notify would notify the parent of the list box when it got created. You can switch it on or off if you want it. And if it's switched on, it will write out, I sent it my notification. So, okay. So in our test, here we build listbox, we assign listbox style, we assign another one to it, we remove LBS sort from it, and then we create the listbox. Let's see if that works. Okay, we compiled it. it gets started, hopefully. Yeah, on the wrong window, on the wrong monitor. And we see test 1 got started, creating this box, sending notification, finished. Everything good. Yeah. Okay, let's go to the second test. Yeah, it's more or less the same. We create the list box, we start the test, we assign it here, we remove sort again, and we create the list box. Okay. So, what do we see now? Test 2 got started, creating list box. Oh, we didn't get a notification. What happened? So let's go back. Now let's go up. So both are in sync. Let's go also here up. So now when I switch over, can you see what changes?
Yeah.
It's over here.
Yeah.
There's another flag of set of bits. There's BS notify. That's button style notify. If we look at button style notify, we see it's totally different defined. Here that's 1 and this just 400. So by simply forgetting this little L, we put on an error into a code and the compiler won't help you at all because everything is an int.
Yeah.
Autocomplete doesn't help you at all either because that's a valid name.
Yeah.
Yeah.
Right. So, okay, let's go on. So, okay, let's assume we create a list box, we create a button. Now we have tests here. We create list box styles, we create button styles, and we create the list box, we create the button. And you already may see what will go wrong.
Yeah.
Okay, now it comes up here. Yeah, we see we created a list box. We in both situations we don't get the notification because we simply flipped the arguments and we're doomed again. Okay. Next test. Let's close that. So. Okay, so again, yeah. So let's try what happens if we, instead of using the Windows defines, we now pretend all those styles would have been defined in enums. Let's try again. What happens? So the code below I didn't change. No, wrong. So no, I didn't. I changed it a little bit. So I create the list box with the button styles, the list box with list box styles. I also put in the broken list box creation, which we had in the second test. And let's see what happens. Now it goes again here. So that's random. So first we create a list box, what we don't get notified. We're creating a totally wrong list box since we're creating it with button styles. And now the second one works. The third one, again, doesn't send us a notification because it checks for the wrong button style inside. And the same for the last two. The first one works and the second one, again, is wrong. So, okay, so let's try harder. Let's, instead of only building up using the enums to create unsigned ints, we now want to have our enums in the interface. So how does this help? So let's see. If we compile, yeah, we will get a lot of errors and we have all these little triggers here. So first of all, we see if we want to create here the enum, we get here an error. So the error is we can't assign the int that's created here to an enum. So we would need a static cast here. The same over here. And also the assignment operator simply doesn't work because it wants to grab his first argument as an int ref and you can't put in an enum for that. Okay, it's the same for the button styles, but now we get an error here when we try to create the wrong list box. So that's good. We captured our first error. But again, let's look at the broken list box creation. There's no error in here. So we can still end the wrong enum with our list, so we can end the list box styles with a button style enum. It works. Okay, let's get on, try even harder. So, now I fixed up everything in here. So I put in like the statics cast that needed. I also turned the assignment operator and I flattened it out. Yeah, then the program runs again. And now we're down to simply this broken list box creation stuff. So, okay. So, okay, what else could we do? Okay, we can go even further, and instead of taking an unscoped enum, we can plug in a scoped enum. What happens then? Okay, let's try to compile. Okay, again, we get a lot of errors, but we get errors at places we wouldn't want them, or we wouldn't expect them even. So now we get an error here at when we want to make an AND between a list box style and a list box style. Okay, it's simply because if we have a scoped enum, none of our bitwise operator is supported at all. We get twiggles everywhere. Even if you go further down, oh, wrong window.
I foresee them.
Yeah, we see this doesn't work. Even I do static cast, so and the negation, everything is simply broken. So we can start from here and try to fix it again. Okay, so
yeah, there's another way things break is when somebody adds on another enumerator that doesn't follow the right pattern.
Yeah, okay, of course, but we can't handle that.
Yeah, but we can.
Okay, we can try. Okay, yeah. So let's see what happens. So for integer types, all operators are supported, no type safety at all. For unscoped enums, all except assignment operators are supported, but still we see implicit integer promotion to all our unscoped enums. And we don't have type safety for mixing bitwise operators between enums. And we need a static cast to return to our enum. Since all the built-in operators return ints. With scoped enums, no operator at all is supported, but we would need a static cast to go to the underlying type, use the operator, and we would use a static cast to go back again. So, okay, here we are.
I think we can all agree that enumerations are the wrong choice for this kind of problem.
Okay, let's see. So, I want to tell you a short fairy tale. This is a fun in the talk, by the way. And yeah, so once upon a time, there was a kingdom which was ruled by the nice Queen of Hearts. And she ruled the whole kingdom with iron fist. Yeah, and the Queen of Hearts, she had her own newspaper, the Daily Queen, which she mostly used to bring out her proclamations. And there were loads of them every day. Yeah. And one of her proclamations was, all proclamations shall be encoded in C++, the Queen. So that's the rule. Everybody has to obey it. So they also had like a font styles enum with bold, italic, and underline, and there was a special style for the Queen's name called Queens of Hearts name, which always had to be used for the Queens of Hearts name. Okay, there was a programmer working for the newspaper, and he was totally down because he had to write Queen of Hearts name so many times until he had an idea. Instead of writing Queens of Hearts names, he could simply write not bold. And it worked. And he could go home early and have a nice time. Yeah. until the troublemaker Alice came to the kingdom. You can see it in your sneaky eyes. So the queen ordered to create a new font style, strike out for Alice's name. And the next day she put in a proclamation to the newspaper. All persons whose name is stricken out are enemies of the kingdom. The queen. As a programmer ran away from the kingdom, he could still hear the queen shouting, "Off with his head." The end. Yeah, that's a sad story. So, what's the moral of this tale I told you? Apart from that the queen is not really a nice person. Though the main moral is that Queen of Hearts name is not equal to not bold. In two ways. In a syntactical way, that the underlying value of Queen of Hearts name is not equal to the underlying value of not bold. And in a semantical way, that not bold is not a set of font modifiers, but it's there to exclude boldness from a given set of flags or of font modifications. Okay, let's look at it in detail. So here we have our bits. The red ones are zeros, the green ones are ones. So we have like italic and underline set here. On the other side we have bold, just the bold bit set. And just looking in that way, there's this nice, if we take the negation, they simply flip from one side to the other. But the moment we introduced the new strikeout bit, we lost this here, because now this is no longer bold. And this is not only here for the fourth bit, it's also there for all the other bits out there. Yeah, and just as it's already here, let's do a little bit of counting. We have here in front, we have the dimension or the number of flags, and we have this additional part that simply flips around every time we make a negation. And we can take the disjunction of both, which simply puts all the bits on, and we can take the conjunction, which pulls all the bits off. So let's now take a mathematical look at everything. Oh, sorry. So here we have like our flag set, which has 4 dimensions, but the underlying type U, let's call it U, has 32 different bits. So it has 32 Boolean dimensions. So U is, together with a negation and an OR, is like a 32-dimensional Boolean algebra. But our flag set, now only with AND and OR, it forms a substructure on it. Let's call it F, with dimension 4 in our case. So, and this flag set is in general not closed under bitwise negation. That's important. But still we can build the closure F bar with respect to this negation. What we get with then is like a 4 + 1 dimensional Boolean subalgebra of U. And we can also look at the elements which are the rest. So we take the closure minus the previously defined flags. And this is just a set of negative flag masks where all the rest of the bits are always set and the 4 bits here in front are flipping around. So, but those types we have to put into a different type. So those elements we have to put into a different type. And for a given enumeration E, the type of flags is E, and the type of negative flag masks I called in my library complement of E, to simply take them apart on the type level so that you can't mix them up. And if we look at the meta level, the type set E and complement E together now with negation and or is a simple Boolean algebra. Yeah, if you negation flips from E to complement of E and back, and takes E and complement E goes down to E, and the OR goes up to the complement. So, okay, but we're still not done. Can anyone spot a problem with this code? So we're having a good old enumeration with 2 flags. And here now we define the operator negation, just taking in a flag and returning, okay, casting to the int, which is the usual. Let's assume we have the usual underlying type int here. We negate it, we cast it back to flags and return it. And here in foo, we just use it to create a mask and yeah, and just take away the bit. Any problem here?
Yeah, well, you're supposed to mask in your remaining bits.
No, the problem is this is undefined behavior. And the undefined behavior happens here when we static cast back. So what's happening? So an unscoped enum without an explicit underlying type infers 2 types. The one everybody knows, that's the underlying type, which is usually an int. But if you read the standard, there's another type that's inferred, and that's a hypothetical integer value type with minimal width, with a minimal amount of bits that can hold all the enumerators which are explicitly in your enum. And this hypothetical integer value type defines the valid value range you're allowed to use for your enum. If you use another value, you're having undefined behavior.
Right. That's why you have to mask it off before you cast it back.
No, yeah, okay, but how would I return it from here? How? Okay, I could mask them away down here, but yeah, then yeah. Okay. But this would require an additional operation, which I don't want to pay for.
Right.
Okay.
There's a better way.
There's a better way. So the thing is, if you do this in const expr context in Clang, you will get an error already. That's great. Yeah. So what did I in my library? I said, okay, complement of flags doesn't use the flag as its value type, but it uses its underlying type as value type. Then we are out of this trouble. By the way, the moment you put in an explicit underlying type here, or you take a scoped enum, you're also out of trouble. Because then all this game with this hypothetical integer type is simply out. And that's good. But still, there are a lot of such enums out there. Okay, so let's talk about the design rationale of my short library. So first of all, I want to enforce type safety with it. For binary operators, of course. And I want to enforce the usage of this complement type or complement template when operator not is in game. So flipping hin and back. It has to be, or it shall be, non-intrusive. So I don't want the user to change its enum. I just want him to let him opt in. Of course, I want zero overhead for my library in optimized builds. Everything has to be const expert to be usable in template calculation stuff and everything. Operators have to be found by ADL just to avoid the stuff we just talked about in the talk before. And the other one, I require at least C++11, and it uses newer features like concepts when they are available. Okay, let's look at the library in action. So where is it? Nope. Okay. Here, find it. Okay. So this is the example I also have in the documentation. Oh no, let's. Okay, let's take this first. So here we have like an enumeration of pizza toppings, which go tomato, and so on, and we have an enum all toppings. You simply enable the enumerate. You enable for my library by. Here we go. So now, nope, a little bit more. Yeah, so you simply enable by defining a single macro. Then we have an enumeration for desserts, which ice cream flavor you want to have. And we have a small function which tells us from the kitchen which pizza in which combination got ordered. We have the same for ordered desserts. And now let's go to the restaurant and order some stuff. Okay, we start building a pizza by taking tomatoes and cheese. We add salami, olives, and we order a pizza. It worked. Okay, we see it over here. Pizza ordered with tomato, cheese, salami, and olives. Now, somebody wants a vegetarian version. He takes away the salami and orders a pizza again. And we see here, pizza ordered with tomato, cheese, and olives. No more salami. Okay. Okay, finally, we want to order dessert. Okay, we got an ice cream, order flavor vanilla. Yeah. So let's now see what happened next. So guest said, okay, I want a pizza without olives. Yeah, down here, pizza without olives. But the waiter says, okay, no olives, but what else to put on it? So no olives is not a pizza. It's not a set of topics. What would you mean everything else? Like, I don't know, gummy or gummy bears on it for children or whatever, ananas for pizza Hawaii. So the waiter says, no, you have to say what you want on it, and then you can say no olives. So, okay, and then the guest says, okay, I want to have all topics on your card, but no olives. And let's put that away again. Okay, it worked. We now ordered a pizza with tomato, cheese, salami, and garlic. Okay, let's see what else could go wrong. Okay, another guest comes and he wants ice cream, strawberry ice cream as a pizza topping. No, not a good idea, and the compiler rules it out. Okay, and last of all, but that's an easy one to spot. Yeah, if we want to order ice cream with pizza toppings, that's also not a good idea. So, okay, so the library rules out all the stuff that shouldn't work. Okay, so questions here?
92 is ruled out by your library or by C++? They are enum class.
So 92 is not ruled out by my library, but simply because the enumerations don't match. So toppings is a set of pizza toppings, and order ice cream wants. Why is order ice cream here? He wants an enumeration of ice cream flavors. So, okay.
So I imagine a macro with a lot of operator definitions.
Maybe we come to that point if we have time enough.
Yeah.
Okay, so yeah, we still have some trouble here. We need to talk about orders on enumerations. So, or on flag sets. Sorry, on flag sets. So we have on flag set enumerations or on flag-like enumerations, we have two orders on them. We have one order induced by the underlying integer type. That's a total order. The integers are totally ordered. I can compare any two of them and it will always be greater or smaller or equal. Yes. But it depends on the enumerator values, which are there, of course. And that's for syntax. That's used for sorting, for sorted containers. On the other hand, we have another order which is induced by entailment of flags we have in a flag set. This simply means A is below B if the flags in A are a subset of the flags in B. So this is an inherently partial order. It's like this multidimensional cube you put onto one edge. But the good thing, this enumeration is independent of the enumerator values because it only looks which flags are set and not at the values. And this is semantics for your flag sets. This is what you think in your head, but you mostly don't use in your program. So sorted containers and algorithms require a total order. So there is a macro in the library which you can put on, it's optional, which would specialize your flag set for std_less. And then it will be picked up by sorted containers and old standard algorithms. But it won't be picked up by std_ranges algorithms because std_ranges algorithms will go for the operator less. They don't go for std_less, but they go for operator less. Of course, you can always plug in the enumeration object explicitly with your algorithm, but we don't talk about that. Yeah. So, but enums are there to. Oh.
So there's also a std_ranges less. How does that?
Is there a std_ranges less?
Yes, it's constrained as opposed to standard std_less, which is not.
Okay, I would have to look that up. Sorry.
I suppose you have to use this macro in the global namespace, right? Otherwise,
no, the macros, all the macros have to be specialized, have to be defined or whatever you say in the same namespace where the enum is defined, so that the functions get found by ADL. The operators get found by ADL.
How can you specialize std_less inside another namespace?
Okay, you're right. That's a problem. Yeah, right. Yeah, okay, right. Yeah, I think I wrote. Yeah, this specialization has to be done at global namespace. Yeah, you're right. But the enabling, this is at the namespace of the enumeration. So enums are there to abstract away the underlying values. So the program logic never should depend on the underlying value of your enum. So I made my favorite one, which you should use if you take the library, is there is a macro which simply deletes all of the relational operators for your enum. It simply says for every comparison is equal delete, and this would force you to plug in the explicit comparison you want to use into each algorithm. That's maybe not the best thing, but it's currently the only way to prevent you from either using the semantical correct less in your program and getting picked up the wrong one for your sorted containers, or the other way around.
I was thinking more about equality and inequality.
Okay, equality and inequality are not a problem, because that's all in both cases the same.
But do you delete those?
No,
Because they're all-
sorry. It only, relational operator only talk about the less and greater and less equal, greater equal, and the spaceship. Sorry, equality and inequality are always there.
Okay.
Okay, sorry. And there are const expr objects, total order and partial order, then defined for your enum, which you can plug into your algorithms, whichever you want to have. Additionally, there are functions for the partial order comparison, like subset, subset equal, intersect, and disjoint to compare the flag sets. The library has additional features like make null for your enum, or make if, where you can plug in a Boolean runtime value, which either creates the flag or a null value, modify and modify in place, add if, remove if, and like get underlying and from underlying, just to not write static casts, or if you use it, you can look them up a lot faster, because it will only pick up those if you search for it and not every static cast in your program. And there's also, it was asked by a friend, a flag generator which generates all the single bits from up to a certain bit. Or like this. Okay, what happens if how to apply Boost.flags to an existing code base? Okay, at first you should change macro definitions and integer constants to enums.
Okay.
If you already have enums, you can leave them or change them into scoped enums. If you would do it, you would have to write everywhere your enum name : but if you're, I think, starting with C++17, you can write using your enum type, and then all the enumerators are hoisted into the namespace. So in that way, you wouldn't have to rewrite every usage, but you get the implicit integer promotion of your value is ruled out, and that's good. You would opt in by Boost.flags enable. There's also a version Boost.flags enable local, which you can use when you want to opt in for a class local enum. Because this thing here simply writes using all the operators that are inside Boost.flags, but you can't write using inside a class there. You have to simply define all the operators as friend functions and forward to the library. So the best thing would be use a scoped enum, and if you had an unscoped, write using enum e below it.
So if the enum is defined inside a class, would it just work to put the enable at the namespace, nearest enclosing namespace?
Yeah, it would work, but then you would have to write two macros, and there is no way to, because you want to have ADL enabled, and you can't check inside the enabling if ADL is really enabled. So you would depend on the user that he put the macro in the outer namespace. You can't check if it's there. But I wanted it, if you opt in, everything is correct at one place.
So what is the release status of this Boost.flags thing? Is it still considered a prototype, or is it in production use?
I use it in production.
Yeah, but
I will show.
Anybody else?
No, nobody
Okay.
else. So I have the intention to propose it to Boost.
Okay.
Let's see if that will come out.
I have some improvements in mind.
Okay, let's talk about it.
No matter.
Of course, you have to change your interfaces from integer type to enums. That would be maybe a lot of work, but it pays out because you get type safety.
Enums or
Yeah,
the flag set.
no, they can be.
No, the enum.
Right,
Your
but I'm
old
just saying
enum.
your interfaces that take, instead of taking an enum as a parameter, they would take this. They would take a set of values.
No. No, I don't change the type at all. It's simply you simply opt in by defining this below your enum. I don't change the enum at all. It's completely non-intrusive. The enum type that you have simply stays as it is. If you already have an enum, if you had like only integers, you would have to change it.
This with the latest client.
Yes. Yes. So, and there would be minor adjustments because this would with an unscoped enum this still works, but with a scoped enum you would have to put like 2 banks in front of it, or there's a function any Boost.flags any which checks if any flag is set, and if you have like a conditional operator, though here you simply can't help because this is an enum, this is an int, and if this is a class enum, they will never get together, and you simply can't do anything about it. The language doesn't let you override the unification here. So, but there's a helper function make if which you could use here, or you write your enum and curly brackets up here and simply generate the right type.
The default value.
Yeah. Okay, and again, it also works with enum in classes, just a different macro because you simply can't use using inside a class. It would be great. So what's in real code? So Epsilon Professional is the program I'm now working on for 25 years. I just checked this morning. I use 120 times. I use Boost.flags enable or Boost.flags enable in local. And yeah, it's in there for now. I don't think I started back like 5 years with this library. I also downloaded the Clang source code and enabled, there were 16 enums only in the Clang part I found which I could enable. There are some enums there which get mixed up with other enums, and this simply doesn't work. Well, but if you look there are comments, oh, it has to be in sync with another enum. And that's smelly, I would say. That's very smelly.
Yes, it is.
Okay, but yeah, sorry, I couldn't find any error in Clang at that point.
So were you tempted to make these optional things into a flag argument to the original macro?
Sorry, can you repeat?
Okay, you have like your Boost.flags enable thing,
Yeah.
right? And then you have things that modify it. I don't remember what their names were, but there are other macros,
Ah, okay.
and those look like flags to me.
Yeah. I tried to. Okay, my first version didn't use macros at all, but that had the problem. Though I just made like const expr functions you have to define, and they get picked up then. But then you get problems with ADL because you're not in the correct namespace. Andrei Simachev, or I don't know how to pronounce him, he pointed that out to me that this is really a problem, and all the operators have to be found by ADL. Otherwise, it has no chance to ever get accepted. So, and the only way to make that work was using macros. Okay, the GitHub repo has a large test matrix. I stole that from Peter Dimov's MP11. It runs on Linux, Windows, Mac. It runs on Clang from 3.9 to 17, GCC, MSVC, and it's running from the Cartesian product where it works for that. And it even runs on some GPUs, also from Peter Dimov. Thanks a lot. Okay, let's compare it to some other flag libraries out there. There's a flag implementation in Qt. There's Jonathan's. Here's like this type-safe library. Here's like a bit set in there. I was pointed out there is Boost bitmask. Did anyone know about it here? Okay, one person. Great. It's almost impossible to find if you don't know that it's there. It's in Boost detail bitmasks. That's there, but it has issues. So let's first look, is it non-intrusive? Yeah, cplusplus, nothing in Qt is non-intrusive. Jonathan's is also not intrusive. Boost bitmap is intrusive. It's just a macro you define. And I've also, I've got here like .NET. I'm not sure if everybody knows there's a language out there, it's called C#, or even with VB.NET, you can define enums and you put an attribute on it and say it's a flag set. And this simply creates a flag set for you. Yeah, and that's obviously non-intrusive. Let's see, 0 overhead, qflags, nowhere at all. All the others are 0 overhead. Const expr, yeah, Jonathan's Boost bitmaps are, yeah, some of them are not. So, but okay, it's just, I talked to you. So here in both cases, the assignment operators, there the const expr is missing, but I don't know if that's ever usable. Maybe in a later language standard.
You need at least C++14, I think.
Yeah, okay. I have to rule that out for 11, yeah. So that it's not undefined behavior. Yeah, that's right. And .NET simply doesn't know about const expr. So type-safe binary operations, I mean by that, can you mix up an enabled enum with anything else that's not an enabled enum of the same type or its complement? Of course, you wanna end the enum with its own complement, or you want to always with its own complement. But as soon as you use one enabled enum with anything that's implicitly convertible to an int, Boost.flags rules that out. You can't call it. Your only option is if you have an explicit override for that operator, it will be picked up, of course. But you usually don't have that, and it's ruled out by the library. So Jonathan's, since it's non-intrusive, it has member functions, it rules it out, but Boost bitmask don't. Boost bitmask just defines the operator overloads for the enum you plug in and let that work, but everything else also works. And .NET is really type-safe in this opinion, in this way. You can only plug in enums of the same type. So what about large underlying T? I mean, larger than int? qflags, no, there's an int which is used. Jonathan, yeah, supports it, great. But Boost bitmarks, again, even it doesn't have the value inside, but it will always cast your enum to an int 32. And you can't get out of it. .NET, yeah, you can have large enums in .NET. And does it have a complement type? Yeah, okay. Jonathan thought about it. Yeah, great. He's a cool guy. But the other, nope, no way. Okay, so there's code, there's documentation on my GitHub account. And questions, remarks?
I want to sit down with you later.
Okay.
Does the bits that you attribute to the flag sets have to be on the beginning of or it could be distributed and have future in the middle of them or stuff like that?
They could be anywhere in the bit set. What the library doesn't support is like having a bit set, and then you have like 3 bits that compose to value between 0 and 7 and things like that. That sometimes happens. Where you use like a flag enum like a C++ bit set. Okay, but if you only have your single bits, they can be anywhere.
Okay.
Maybe I need to, but do you find a trick to generate these powers of 2 or then?
Yeah, sorry. There's one. No, there's a function, simply nth bit I have in there.
Oh yeah, I saw that one. But
Yeah, okay, but
0, 1, 2, 3. Huh?
you could mimic it if you make it non-intrusive, and of course take a macro where you make like a next element and then generating from the an auto-generated next element, and then you make some calculation, take one less, and then make the shift. And yeah, but that's awful. We should have language support for flags, or at least something where you can say, I don't want a +1, I want a ×2 for the next enumerator. That would be great.
Or yeah.
Or built-in flags would also be great.
If I have an unknown value that composes 2 flags, like a bold italic or something like that, does it support that? So I have bold, italic, underline, and then I have bold italic that just composes 2 bits there.
As a single enumerator in your flag set.
Yeah,
that works. We had that in the pizza toppings. We had that all topics, which simply was the big O of all the other topics. Toppings. Sorry. Yeah, you can build like flag sets in your enum. Yeah, and you can, or on the other end, you can make like const export definitions outside of your enum, and they work like everything else in there. It's okay. Then, thank you. Oh.